Hello everyone, I am Abhijit Lal, Assistant Professor, Department of EEE, BIT Durg. Today we are going to study about the concept of preventive maintenance. So this will be the content for today's lecture. So let's start with the introduction of maintenance. So let's start with the introduction. Maintenance of electrical equipments. It is the process of ensuring that electrical equipment is kept in good working order. It includes inspecting, testing and repairing of electrical equipment as necessary to prevent problems that could lead to a loss of power or an electrical fire. Now let us discuss the types of maintenance. So first type of maintenance is preventive maintenance. Next is reliability centered maintenance. Third one is condition based maintenance. And fourth one is the combination of condition based and preventive maintenance. Now let us discuss about the preventive maintenance. The preventive maintenance is the practice of maintaining equipment on a regular schedule based on elapsed time, runtime meter readings or number of operations. The intent of preventive maintenance is to prevent maintenance problems or failures before they take place by following routine and comprehensive maintenance procedures. The goal is to achieve fewer, shorter and more predictable outages. The advantages of preventive maintenance are: it is predictable, making budgeting, planning and resource leveling possible. When properly practiced, it generally prevents most major problems, thus reducing forced outages, reactive maintenance and maintenance costs in general. It gives managers a level of assurance that equipment is being maintained, and also it is easily understood and justified. Now let us discuss about the maintenance and test procedures which are applicable for different electrical equipments. The electrical maintenance activities fall into three general categories. First is routine maintenance, next is maintenance testing and third one is diagnostic testing. So first is routine maintenance. Activities that are conducted while equipment and systems are in service are called as routine maintenance. These activities are predictable and can be scheduled, staffed and budgeted. Generally, these are the activities scheduled on a time-based, run-time meter-based or a number of operations schedule. Some examples are visual inspections, infrared scans, cleaning, functional tests, measurement of operating quantities, lubrication, oil test, governor and excitation system alignments. Next is maintenance testing. The activities that involve the use of test equipment to assess condition in an offline state comes under maintenance testing. These activities are predictable and can be scheduled, staffed and budgeted. They may be scheduled on a time or meter or number of operations basis but may be planned to coincide with scheduled equipment outages. Since these activities are predictable, some offices consider them routine maintenance or preventive maintenance. Some examples are double testing, measuring, relay testing, circuit breaker trip testing, alternating current high potential which is also called as high pot test, high voltage direct current that is HVDC RAM test and battery load test, etc. The third one is diagnostic testing. So the activities that involve use of test equipment to assess condition of equipment after unusual events such as faults, fires or equipment failure or repair or replacement or when equipment deterioration is suspected. These activities are not predictable and cannot be scheduled because they are required after a forced outage. Each office must budget contingency funds for these events. Some examples are double testing, AC high pot test, HVDC RAM test, partial discharge measurement, wedge tightness, core magnetization test, pole drop test, turns ratio, and core ground tests, etc. Now let us discuss about the fault and load flow studies or equipment ratings. Electrical power systems change as new generation and transmission lines are added or modified. Changes also occur as new equipment is added or upgraded inside the power plant. This may mean that load ratings of various equipment and interrupting ratings of breakers and fuses are no longer adequate. Underrated or misapplied electrical equipment can be hazardous to personnel, to the integrity of the power plant and power system, and to the equipment itself. Therefore, it is necessary to periodically conduct fault and load studies and to review equipment ratings for adequacy or continuous current, momentary voltage, basic impulse insulation level, which is also called as BIL, current interrupting ratings, etc., and for coordination of protective relays, circuit breakers, and fuses to ensure safe and reliable operation. Now let us discuss about the maintenance schedules and documentation. The complete, accurate, and current documentation is essential to an effective maintenance program, whether performing preventive, predictive, or reliability centered maintenance. Keeping track of equipment condition and maintenance performed and planned is critical. The maintenance record keeping system must be kept current so that a complete maintenance history of each piece of equipment is available at all times. This is important for planning and conducting an ongoing maintenance program and provides documentation needed for the power, operation, and maintenance reviews. So, regular maintenance and emergency maintenance must be well documented, as should special work done during overhauls and replacement. The availability of up-to-date drawings to management and maintenance staff is extremely important. Accurate drawings are very important to ongoing maintenance, testing, and new construction, but they are essential during emergencies for troubleshooting. In addition, accurate drawings are important to the continued safety of the staff working on the equipment. Now let us discuss the electrical equipment maintenance schedules. Starting with the first equipment is annunciators. Now what is annunciator? Annunciators provide essential plant condition status information to operation and maintenance personnel. The figure shows a typical picture of an annunciator, and these annunciators are placed in the control panels of the generation unit or the transmission unit or the distribution unit. The two aspects must be considered. First, the correct operation of the annunciator itself and integrity of the alarm devices and interconnected wiring. Annunciator operation is easily tested using the test button provided on most annunciators and is considered an operations activity. Verifying integrity of the alarm devices and interconnecting wiring requires a functional test of these circuits. Functional testing is accomplished by resetting the annunciator, secondly closing or opening contacts at the alarm device, and verifying that the correct annunciator window is activated. It is recommended that the alarm device actually be triggered where possible for best assurance. However, it may be necessary to simulate contact operation with a jumper or lifted lid when device activation is not possible. Annual functional testing of annunciators is recommended for best assurance of integrity. However, this may be considered too extensive for time and resource limitations. In these cases, functional testing of those alarm points that indicate impending shutdown or failure that could be mitigated by operator action is still recommended. Functional testing of annunciators also is recommended after a major outage or after modifications that affect wiring and cabling in the plant. Now the following table shows the maintenance schedule for annunciators. So the operational test is performed in each shift for staff plants and each visit for unstaffed plants, and the functional test is performed annually. Now the second electrical equipment is arrestor. So the lightning or surge arresters provide protection for important equipment from high energy surges. These arresters are static devices which require fairly infrequent maintenance. Most maintenance must take place while the associated circuit is de-energized. However, crucial visual inspections and infrared scans can take place while energized. The following table shows the maintenance schedule for arresters. So the first maintenance or test is review equipment rating. This is done every 5 years. Second is visual inspection with binoculars. This test is done quarterly to semi-annually. Next test is clean insulator and check connections. This is performed 3 to 6 years or the ambient dependent. Next test is double test, which is the power frequency, dielectric loss, dielectric current, DC insulation resistance, power factor determination. This is performed every 3 to 6 years and also it depends upon the ambient. Next test is to replace all silicon carbide arresters with metal oxide varistor type. This can be done as soon as possible when it is available. Next test is the infrared scan. It is done annually. Next equipment are the batteries and battery chargers. Battery systems provide last resort power for performing communication, alarm, control and protective functions when other sources of power fail. Battery system maintenance should have highest priority. Computerized online battery monitoring systems can greatly reduce maintenance required on battery systems and actually improve battery reliability and increase battery life. The battery chargers important to the health and readiness of battery systems require regular maintenance as well. The below table shows the maintenance schedule of battery chargers. The first test performed is the preventive maintenance. It is done depending on the charger type and manufacturer's recommendations. Next test is the infrared scan cables and connections if visible. It is done annually. Next is the maintenance schedule for the flooded or wet cell or lead acid batteries. First test is the visual inspection. This should be done monthly. Next is battery float voltage. This is done the shift wise, that is through the charge meter, and monthly by overall battery voltage with digital meter compare with charger meter. Next is cell float voltage. This is done monthly, pilot cells with digital meter and quarterly with all cells. Next test is specific gravity. This is done monthly with the pilot cells, done quarterly for 10% of cells and annually for all cells. Next test is temperature. This is done monthly for a pilot cell and quarterly for 10% of all the cells. Next test is the connection resistance. This is done annually for all connections. Next is capacity testing. This test is done every 5 years or annually if capacity is less than 90%. Next test is safety equipment inspection. This is done monthly. Test all wash dishes and inspect all safety equipment. Next test is the infrared scan cells and connections. This test is performed annually. Next is battery monitoring system. This is done according to manufacturer's recommendations. Now let us discuss about the maintenance schedule for vented nickel cadmium batteries. The first test performed is visual inspection. This is done monthly, in which the fluid levels are checked. Next test is the battery float voltage. It is done in every shift, that is that is with the help of charge meter. It is performed monthly, that is compare charge meter with digital voltmeter. It is performed quarterly, in which the pilot cell is checked with digital voltmeter. It is performed semi-annually, in which each cell is checked with digital voltmeter. Next test performed is to measure the temperature. This is performed quarterly with any pilot cell. Next is inter-cell connection retorque. This is done annually, that is retorque to specifications. Next is capacity testing. This test is performed every 5 years or annually if capacity is less than 90%. Next test is safety equipment inspection, which is done monthly, in which test all watch devices and inspect all safety equipment. Next test is the infrared scan cells and connections, which is performed annually. And last is the battery monitoring system, which is performed according to manufacturer's recommendations. On next equipment are the buswork, enclosures and insulators. Buswork conducts current from one part of the power plant or switchyard to another. Buswork is usually constructed of flat or round copper or aluminum bus bar and can be either isolated, phase or non-segregated. Except for infrared scanning, bus maintenance must be conducted de-energized. Standoff buswork insulators provide isolation of live power circuits from ground and other circuits. Failure of insulators will cause a power system fault and a forced outage. Now, the following table shows the maintenance schedule for buswork and enclosures of the rating 5 to 15 kilowatts. The first test performed is review equipment ratings, which is performed every 5 years. Next is external visual inspection or check and tighten connections and check and clean enclosures. This is done annually. Next test is hypot, that is to ground and between phases or double. And this is performed 3 to 6 years or ambient dependent. Next is the infrared scan while loaded if possible. This test is performed annually. Now let us discuss the maintenance schedule for buswork insulators. In this, the first test performed is double, hypot or Megger or the individual insulators. This is performed only when problems detected in buswork and enclosures. Next test is the infrared scan while system is loaded if possible, and this is performed annually. Now the next equipment is power cable of the rating 5 kilovolt and above. High voltage cable conducts power between the power plant and switchyard. The cable may be solid dielectric or oil filled. In the case of critical circuits, periodic maintenance tests are justified during the life of the cable to determine whether or not there has been insignificant insulation deterioration due to operational or environmental conditions. Direct current hypot tests effectively reduce in-service failures from faults of the cable or its accessories. When done properly, maintenance tests can detect problems in cables that are approaching failure without accelerating the deterioration process. Except for infrared scanning, de-energize the cable circuit before maintenance. Now the following table shows the maintenance schedule for medium and high voltage cables, solid dielectric and oil filled. The first maintenance or test performed is the review equipment ratings. This is done every 5 years. Next is DC hypot test, that is the stepped or ramped voltage method. It is performed 1 to 3 years. Next is oil test or the dissolved gas analysis, which is also called as DGA. Dielectric, acidity, color, interfacial tension, water content or power factor measurement. This is done annually for oil filled cables. Next is visual inspection and infrared scan while loaded. This is performed annually. Next equipment is the circuit breaker. Circuit breakers interrupt electrical current to stop power flow both for switching operations and during fault conditions. Molded case circuit breakers are usually located in low voltage distribution panels and in control boards. These are typically 120 volts alternating current, 125 volts direct current, 240 volt AC and 480 volt AC breakers for control, protection and auxiliary power. Molded case breakers in panel boards should not be loaded more than 80% of rating. Low voltage air breakers are usually located in motor starter cabinets, motor control centers, station service switchgear or similar enclosures. These are typically 480 volt AC for auxiliary power. Medium voltage circuit breakers are generally located in station service metal clad switchgear or in separate enclosures as unit breakers. Examples are 4160 volt AC station service, 11.95 kV and 13.8 kV unit breakers. These breakers may be air blast, vacuum or SF6. High voltage circuit breakers are located in separate breaker enclosures either indoors or outdoors. These are oil, air blast or SF6 breakers. Examples are 115 kV and 230 kV breakers located in the switchyard. Now let us discuss the low voltage, that is 600 volt and 400 volt and below that circuit breakers which draw out air breaker maintenance schedule. The first one is review equipment ratings. This is performed every 5 years. Next is preventive maintenance and inspection. It is done as per the manufacturer's recommendations or after 1 to 3 years approximately. Next is insulation testing and overcurrent and fault trip settings and testing. This is performed between 1 to 3 years or after 3 years maximum. Next is visual inspection and infrared scan while loaded or immediately thereafter. This is performed annually. Next is the medium voltage, that is 600 1 to 1500 volt AC vacuum breaker maintenance schedule. Again, the first one is the review equipment ratings, that is which is done after every 5 years. Next is preventive maintenance as per the manufacturer's instruction manual. Next is record meter readings, which is performed annually. Next is record operations counter, which is performed monthly. Next is to check foundation, grounds, paint, check external screws, bolts, electrical terminals, etc. This is performed annually. Next is to contact resistance measurement, motion analyzer, trip test, etc. This is performed as per manufacturer's instruction manuals. Next is the double test or AC high pot, including across point contacts and to ground. This is performed every 5 years. Next and the last test is the infrared scan and visual inspection, loop clean, adjust, align control mechanisms. This is performed annually. Now let us discuss about the medium and high voltage SF6 breaker maintenance schedule. The first is the review equipment rating, which is performed every 5 years. Next is preventive maintenance, which is performed as per manufacturer's instruction manual. Next test is the record gas pressure and temperature or compare with tolerances, which is performed monthly. Next maintenance procedure is the record operations counter, which is performed monthly. Next is visual inspection, which is performed monthly or annually or every 5 years. Next is check foundation or grounds or paint, which is performed every 5 years. Next is check external screws, bolts, electrical terminals, etc., which is performed annually. Next is contact resistance test or power factor insulation test, motion analyzer, trip test, moisture test on gas, which is performed every 5 years if required by manufacturer. Next is verifying operation and calibration of temperatures and pressure switches and gauges, which is performed every 5 years. Next is check loop points, heater operation, tightness of terminals, linkages, screws, bolts, latch, linkage, operating mechanism adjustments, which is performed every 5 years. Next is overhaul breaker with new seals, contracts, nozzles. This is performed 10 to 15 years or 4,000 to 10,000 operations, which is more frequent. Next is overhaul disconnect, grounding, and braking switches. This is performed every 15 years or 5,000 to 10,000 operations, which is more frequent. And last one is the gas card maintenance, which is performed as per manufacturer's instruction manuals. Now let us discuss about the high voltage, that is greater than 15,000 volt AC oil circuit breaker maintenance schedule. Next is the preventive maintenance, which is performed as per the manufacturer's recommendations. Next is visual inspection of breaker and bushings, performed every 2 years as per manufacturer's instructions. Next is breaker and bushings double test, which is performed between 3 to 5 years. Next is contact resistance, which is performed as per manufacturer's recommendations. Next is breaker timing by motion analyzer, which is performed as per manufacturer's instructions. Next is bushing, that is double with hot collar, performed every 3 to 5 years. Next is for bushing, that is cleaning, which is performed every 3 to 5 years. Next is infrared scan, which is performed annually. Next test is the insulating oil double test for power factor and dielectric strength and dissolved gas analysis. This is performed between 3 to 5 years. And last one is test stripping circuits, which is performed between 3 to 5 years. Now let us discuss about the generators in large motors. Generators produce electrical energy from mechanical power transmitted from the turbine. Large motors drive pumps to move water. Generators and large motors included in this section are synchronous machines performing the primary function of the power or pumping plant. Let us discuss about the maintenance schedule for generators and large motors. The first one is preventive maintenance and inspections. No standard recommendation interval is required. The machine specific preventive maintenance according to the site operating conditions are performed. Next test is the stator winding physical inspection. This is performed during first 2.5 and 5-year warranty inspections, thereafter during major maintenance outages, but not exceeds 5 years. Next test is for stator winding, that is high voltage DC ramp test. This is performed between 3 to 5 years and after prolonged maintenance outage. Next test again for stator winding is insulation resistance polarization index, which is performed in lieu of HVDC ramp test. Again, next test for stator winding is AC high pot test. It is performed at factory and as an acceptance test, non-routine thereafter, but may be used to verify insulation integrity before and or after stator winding repair. Next is the partial discharge measurements, online monitoring with partial discharge equipment for stator winding. This is a non-routine test performed if problems are suspected. And last one is the blackout test for stator winding. This is again a non-routine test which is performed when deterioration is suspected. Next test is the stator winding ozone measurement. This is again a non-routine test which is performed when deterioration is detected. Next is wedge tightness measurements. This is performed during first 2.5 and 5-year warranty inspections. Thereafter performed after rotor is removed, particularly if unit is operation for 20 to 25 years without re-wedging. Next one is stator winding power factor measurements by double test. It is again a non-routine test and may be performed in conjunction with other generator condition test. Next one is stator core or physical inspection. This is performed during first and 2.5 and 5-year warranty inspections, thereafter during major maintenance outages but not to exceed 5 years. Next is stator core or core magnetizing test. It is again a non-routine test and should be performed prior to rewind or if core has been damaged. Next test is on rotor, which is the physical inspection, and it is performed during major maintenance outages but not to exceed above 5 years. Next test on rotor is insulation resistance polarization. This is again a non-routine test which is performed when deterioration is suspected. Next test on rotor is AC pole drop test. Again, it is also a non-routine test which is performed when deterioration is suspected. And last is the thrust and upper guide bearing insulation test. This test is performed annually. Now let us discuss about the motors uh, which are having ratings below 500 HP. So, motors of this type drive pumps, valves, gates and fans. They are usually induction motors and are generally less than 500 HP but may be somewhat larger. Critical motors should routinely be tested. Now let us discuss about the maintenance schedule for motors. So first test is the insulation resistance, which is performed annually, and next is infrared scan, which is performed annually. Next equipment is the station or distribution transformer under 500 kVA. So the station and distribution transformers generally operate at relatively low voltages and power ratings. They provide step down power to supply plant auxiliary loads. For example, a 480 to 240/120 volt AC transformer that supplies power to auxiliary lighting panels. The following table shows the maintenance schedule for station and distribution transformers. The first test is the review of equipment ratings, which is performed every 5 years. Next is infrared scan while loaded. This is performed annually. Next is double test if oil filled. This is performed between 3 to 6 years. And last one is the dissolved gas analysis if oil filled transformers are used. These are performed annually. Next is the instrument transformer. The instrument transformers convert power system level voltages and current to levels safe to feed meters and other low voltage and current devices. Voltage or potential transformers generally have output in the 240 to 180 volt AC range, while current transformers have output in the 2.5 to 5 ampere range. Over the course of time, instrument transformers, particularly the current transformers, may become overburdened with the addition of more devices in the secondary circuit. This may lead to saturation during a fault, which may cause the relay to misoperate. Periodically measuring secondary burden and comparing it to the transformer rating will indicate if this is a problem. Instrument transformer secondary wiring always should be checked for integrity after any work that may have disrupted the circuits. Instrument transformers that are oil filled will fail catastrophically and cause hazards to workers if not maintained properly. Any oil leak should trigger immediate double testing and replacement planning. The following table shows the maintenance schedule for instrument transformers. Again, the first one is the review equipment ratings, which is performed every 5 years. Next is burden measurements, which is performed every 5 years. Next test is double test for oil filled transformers, which is performed every 5 years. Next is visual inspection. This test is performed annually. And the last test is the infrared scan, which is performed annually. Next type of equipment is the dry type power transformers, rating of 500 kVA and above. The dry type power transformers are air cooled, having no liquid insulation. Typical applications include station service and excitation system transformers. The maintenance schedule for dry type power transformers include the review of equipment ratings, which is performed every 5 years. Next test which is performed is the infrared scan, which is performed annually, and last is the temperature alarm check, which is performed annually. The next test performed is the visual inspection, which is performed annually. Next maintenance or the test performed is to check the fan operation, which is performed annually. Next is to clean the fans and filters, which is performed annually. Next is the turns ratio test, which is performed between 3 to 6 years or if problems are suspected. And lastly is the mega windings or hypot test. This is performed every 3 to 6 years or when problem is suspected. The last equipment is the oil filled power transformers. Oil filled power transformers generally deliver power to and from the main units of the facility. For example, generators step up transformers. These transformers are generally located outside the building in a transformer bay or in a switchyard. These transformers may be 2 winding or more and include auto transformers. The maintenance schedule for oil filled power transformers are the review equipment ratings performed every 5 years, preventive maintenance as per the manufacturer's recommendation, transformer physical inspection, which is performed annually. For bushings, the test performed is the visual inspection, which is performed quarterly or between 3 to 5 years. Next check for the bushings is the check oil level, which is performed weekly. Next test for bushing is the cleaning of bushing, which is performed every 3 to 5 years. Next is the transformer and bushings double test, which is performed between 3 to 5 years. Next is the infrared scan, which is performed annually. Next is the insulating oil or the DG and physical chemical test, which is performed annually after first year of operation. And last is the core mega test if DGA indicates. Now the different tests which are also performed are the leakage reactance or the turns ratio test or SFRA test. This is performed if problems are indicated by other tests. Next one is the cooling fans inspection and test. This is performed annually. Next is oil pumps and motors inspection and test, which is performed annually. Next is the heat exchanger inspection, which is performed annually. Next test is on the conservator and bladder to inspect, that is performed between 3 to 5 years. Next is top oil and winding thermometers, which is performed annually. Next test is oil level indicator operation, which is performed every 3 to 5 years. Next is pressure relief device. This is performed annually to inspect and perform function test, 3 to 5 years to check oil leaks. Next is sudden pressure relay, which is performed annually to inspect and perform functions test, 3 to 5 years test per manufacturer's recommendations. Next one is to test or maintain Buckles relay. This is performed annually to inspect and perform function tests. And lastly, to inspect foundation, rails or tracks. This is performed between 3 to 5 years. So in this way we have discussed the different maintenance schedules of different equipments which comes under the preventive maintenance. Thank you.